Ready? Okay. So if everybody's ready, we're gonna start. Hello, everyone. Thank you for being here. This is Vijay. I'm Andreas. We're the co-founders of Fileverse. For those who know, we've created ddocs.new last year. We released it. It's an alternative to Google Docs, decentralized, privacy preserving, etc. What we're going to talk about today is a little bit different. It's an experimental project that we started maybe a month and a half, 2 months ago, something like that. And it was in response to a pretty worrying trend we've been seeing online, especially in crypto, which is, it's the second time, at least in my memory, that we get the opportunity to really shape the world significantly. Early days, it was just the internet in general. Now it's AI. I consider those two significant technological forces that are shaping our world. And already within the first few years, and in crypto, few months of AI agents becoming important, integrated a bit everywhere, everybody tries to create a project around it, we're starting to seeing the same centralized forces that have made the internet full of walled gardens, full of inability for you to port your data from one place to the other, which, by the way, is a requirement under GDPR. Same for Californian data protection laws. So we're seeing the same patterns that brought us the centralized internet and the cloud empires being repeated with AI agents. So this experiment was a way to actually drive us away from that, at least give really easy developer tooling for developers that want to implement some AI agents, but do not want to deal with the hassle of, I need to think of the storage layer, addressing, authentication. I need to make sure that maybe it has some interoperability with some apps, some other agents, etc. What kind of file format are you going to be using? How is it? How easy or difficult is it for other agents to process the data outputs of your agent? A lot of those considerations. So Vijay and I created this SDK, and the rest of the team, of course. And it kind of facilitates all that work for you. So you don't have to think of where you're going to store the outputs of your AI agent, the inputs it receives, etc. That's one dimension of what this SDK is good for. And the second dimension, so moving away from that centralized force that is currently propagating in the open source AI work. And the second dimension, which is quite important, is this concept, which is much more experimental, that what if all agents on the internet that are doing public, semi-public work, for example, one that we're seeing a lot of use cases around is processing all the governance proposals happening today, the votes that are associated to it, to them, the commenting, the type of social dynamics, the credibility of the different people that are participating in the governance process. All that, people are starting to integrate AI agents to facilitate the work of actually consuming that information, making sense of it, etc. Unfortunately, this happens behind closed doors. So, along with a few other people in the community, we came up with this idea. What if we took an original idea of the Ethereum white paper, which was to make Ethereum into a shared memory layer for decentralized apps to be possible, and apply it to AI agents? And this is what you're seeing right now. I'll just finish with a quick not introduction, but overview, and then I'll let Vijay get cracking with the actual walkthrough. For those of you that want to set it up, set an agent up, have its memory, its outputs or inputs taken from peer-to-peer networks on chain, etc. So what happens here is you'll be able to set up an AI agent. You won't have to think of its storage layer. The storage will happen on peer-to-peer networks like IPFS or Swarm. Both are integrated at the moment. And we just received a PR as well from those who are familiar with the Waku team, the Codex team. They just added also their storage layer for those agents. it's been picked up quite a bit already, despite being a really experimental project. So I'm quite happy, and I hope it will give way to a few questions and good discussions. Um, so your agent will be able to deploy a smart contract on chain. It will be its identity, let's call it. It will be their multisig, how they manage the content that they're posting on chain. There will be a registry of content hashers coming either from IPFS or Swarm. So really, the blockchain component here is really to have a common layer for addressing any type of storage, even S3. And you'll be able to have any agent that you've deployed see the memory of other agents' outputs. So if 10 other agents have been posting their assessment of proposals happening on the governance of different DAOs, then your agent will be able to process their outputs as well and use it to come up with better assessments for whatever task you've given it. So I'll stop here so that we can get cracking with the technical part. But I hope it gives you a bit of an overview of why this exists, why it's a nice experiment, and what kind of discussions we can have around it. Vijay.
Yeah, and to give a like sort of a technical side of the same story, which is like why it's a very important key piece that we have here, is because today, if whatever AI agents that you're using, what you're doing is like you're putting your prompts on that particular UI, whichever you are using to interact with, and then whatever the output is generated, even that is stored on those servers and places. So what's going to happen if these once these companies run out of money to continue running that infrastructure is like you sort of lose that history of whatever interactions you have had with them, right? With any kind of AI agents that you're talking to, with whatever type of workflows that you have worked on or like did the things with. And that's why you have some alternates that already exist. For example, like you should use a local first AI that like local first app that connects to the AI and then keeps track of all the systems. But here, what I'm going to show is like how do you do that in any kind of workflow or wherever you're thinking of integrating that agent for your like tech workflow, let's say, and how you can leverage the storage layer without necessarily worrying about all the components that are required to make it work. So this is the package that I'm going to use, but that's something that I can explain a bit more. Let's go and see here. One sec, let me increase the size. Yes. So there are different use cases that you are already using the AI agents in. So I'm going to highlight each one by one so that it's clear on where exactly you can plug and play this piece and it can work. So to give you an idea of, for example, like right now you might have a very simple workflow is like you go to an AI agent, you talk to it, and you send a prompt. So in this case, I'll highlight it here. So what you do is like you, let's say you set up your LLM and then you send a prompt to it, it sends back some response, and how do you put that and where do you put that, right? At the moment, what you would need to do, like if this this piece doesn't exist, is like you would have to upload it either to IPFS or to some form of data store or to some form of like storage layer for it to persist and then later on refer back to. So let me run this. So in this case, what's going to happen? I can go into the each thing. So what we are doing is like we're setting up a storage provider. It can be essentially anything. Right now I'm showing it with Pinata, but it can be Swarm. And if you want, you can even use any kind of, for example, local first thing as well. Like you can plug this, like you can look at this API structure that this particular piece provides. One sec. So it should show. Yes. So basically, if you take a look at this, it just requests like if you want to upload something, how do you download from there, and then what is the protocol that exactly you want to connect to, and you just need a way in which you say that whether it's connected to it or not, right? So while this output is running, I'll show you that where this thing got published. So you can see that it was published on chain and it should be listed here. So what was the output that we are looking at? So here I just did a conversation log and in which I asked a very simple question to this agent saying how to make tomato soup. Spelling is wrong, but that's different. So you can take a look at this conversation log, and in this conversation log, what happened here is one sec. I can describe it from here. Yes, is this agent, this LLM agent, Quen 3.6b model. It responded with the recipe of how to make it, and what it did is like it uploaded it to IPFS on this IPFS hash, and like put it on the content registry that we have built. And the way that it is the way that it is useful is like you can go to the different use case, which is, let's make it even more complex. What if you have the agent that is running the for example that is running somewhere and it wants to refer back to the output that it has previously generated, right? So I'm calling this log with memory, meaning how do you uh, start a prompt, create an output, then use that outputs, for example, uh, refer that output back in your different use case. So if I run it like this, by the way, if you want to follow, you can go to this repo, github.com/fileverse/protocol Berg v2, and you have everything that I'm running here. So once I do this log with memory. So in this case, what's happening is first it initialized a memory file on this content registry, and then it took that memory file. It did a conversation with the agent, in this case, this place, and then it summarized that conversation and then updated the memory file. Now, this is the second type of use case where you want to refer back to the output of the agent from a previous interaction that you've had. And this is the way in which you can do it. And one more thing. Yeah, so these are the two interesting ones. Then there is another use case. For example, like if you have 2 or 3 LLM agents that are talking to each other, and how do you put that interaction uh, first into the output that is understandable by the other agent, and then you take that output and put it onto a content registry or wherever you'd like to host it, right? So in this case, what I'm doing is I'm setting up 2 LLM agents, and they're talking about a topic, why is the sky blue? And they're going to do back and forth for 3 rounds, and then that thing will also go on chain or on this content registry. Meanwhile, I'll show you the previous output that was published. So it goes here. Okay. So in this case, this is the file that got updated with the content log, and it did a summary of it and added it as well. That's the second thing. Okay, so in this case, the way that these LLM agents are interacting is like they're just doing back and forth of different things that they are talking about, and the entire interaction will then be converted into .md and then will be put on this storage provider that we are using, in this case Pinata, and that will update the content registry of ours. at the end. Okay, so this is done. Yeah, so I'll show, I think, this output, I think. Hmm. Okay, so file got created. I'll show you the thing as well here. Yes. So in this case, what happened is the first round basically means that initially what did both models say? I'm using a very basic model at the moment because it's like I wanted to do the demo and not just wait for them to think and show the output. Uh, in this case, they just discussed things, and then the other model comes back and adds their opinion, and so on and so forth. But here, the key thing that is there to note is that it's whatever output is generated from here, it's completely readable by the other model. And in terms of architecture, it makes it much more simpler for anyone else to create parallel apps that can collaborate with these agents. And it gives them sort of a shared space or a shared memory for them to read off of and then write to as well. I'll show one interesting case also, but I want to first draw something. So basically, let's say there is a shared memory that we are talking about, and in this case, the shared memory is something like this. So you have agent one that, let's say, puts a question saying uh, how to do a workshop structure, right? Let's say that's the question that the agent asked. Now, in this case, the just because this shared memory is actually on chain, meaning on uh, the shared state, or let's say blockchain in this case, the other agent can actually just directly read from this shared memory and respond to it if and when they need to, right? And I'll show this example actually in the script that I have, in which one agent publishes something and the other agent responds on the basis of what it hears from that agent, just because the registry is shared. And this was an example that Andres also mentioned, which is like, for example, imagine there are different proposals that are published. There are different uh, like on-chain actions that are taken. And in response to that, you want to be able to react or like have your agent respond or do anything you want. And having a shared space in this case helps. And I'll show the example of it. Let me split the thing. So in this, what I did is like I wrote first one is publish LLM, meaning it's something that is going to publish something somewhere. I can change the question to, let's say, this thing. Yeah. And then there is this subscribe LLM, which is actually listening to the on chain action that's happening on the shared memory and going to react to it. So if you want, I can highlight the code as well where it does it. So, for example, in this case, if you take a look at this watch contract event, so what it's doing is it's listening on this smart contract registry and it's listening for one specific event called added file, and on the basis of that it's going to do this action which I've written here, which is first read what's on that particular place and then summarize this in 5 sentences and then publish the output on chain. So that's the whole flow that I'm going to describe. So first I'll run the subscribe LLM. So node multi-agent subscribe LLM.js. Yes. So in this case, the listener is active. I'm going to run the second instance of the model. Let's go node multi-agent publish LLM. So if I take a look at the publish LLM, it's very simple. In this, I reuse the log structure, but if you want to understand, it's basically what it's doing is like it's responding to the prompt and pushing that conversation on the same shared state. Okay. Oh, all right. I did not save it, so let me rerun. So in this case, what happened here? Ah, okay. It might be the previous transaction that got published. Yeah. So once this agent creates this conversation, the subscribe agent is going to listen to it and make the change. So yeah, that's mainly what should say. Hmm. Okay, I think there is some bug. Let's see. So this. Okay, let me try something here. Yep. Yeah, so to simplify, what I'm going to do is I'm going to remove this conversation loop from here. Let's, so that it's faster and we can test things. Okay, this is not defined, so this goes prompt. Cool. And if you have any questions or anything, feel free to ask. And if you want, you can clone this repo to actually run all of these things on your side, right? So it says, okay. Hmm. Sure. Mm-hmm. So basically, it depends on which chain you are deployed on. Actually, that's the first. Not Ethereum. Yeah, not Ethereum. Yes. Yes. So the key thing is like actually we don't want to be the one that control the what can be added on this. So to give you an idea of how easy it is, like you can go and add whatever type of storage layer you want here. Just add the follow the proper interface and add it, and we'll merge that and it works. Then you have for chain specifically, like you just need to update one thing I'll show you as well. And in this, like you just go and add your registry here, which registry you want to use, and you're good to go. You also need to make some changes with respect to the, like maybe if there is a compatibility issue with the chain with Vim or with Pimlico, those small tweaks, but it should work out of the box, because what we have done here is like we have brought all of those components together in a way where none of the components are causing vendor lock-in, right? And that's the reason why we give the storage layer to, for example, to have the options of Pinata, Swarm, or any kind of thing that you want. You can even host it on your local or S3 or wherever. Because at the end of the day, the reason why we did this experiment, or why we are like actually uh, put time into this, is because we were concerned of how the you know, ability to move away from conversation agents is being taken up or being absorbed, just because nobody's working on improving the DX for not letting that happen, right? So we're open to contributions. Anything that you think that you want to add on, we'd be more than happy to do this. And like, that's why we made it so simple, so that you can just try and check what is happening and where it's going, or what can you do to tweak it, right? Yeah, I was able to fix the bug as well. So I think this is the other agent that responded. If you take a look, the first agent did something, and the second agent responded in uh, turn of that. So if you want, you can run this script, and it does exactly what I described, and is very straightforward to plug into your systems. And that's why I showed you four different use cases which you might think of or using doing this. So yeah. Yes. Yeah. 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 So it's this simple actually to add a storage provider. The thing that I was highlighting, you just need to make changes to 3 4 files, and all good. Yeah. So they just added this Codex storage provider, which is a derivative, or you can say the implementation of base storage provider, and it just works. Yes. Yeah. Yeah. So exactly. The agent that is running is like, right now I'm using Olama. It's the easy solution that you can use for example, running it locally. Any kind of agent that you want, you can use DeepSeek or whatever type of models you want. But it's this function that you need to change, which is how do you set up your LLM and how do you chat with it, that you need to implement. If you want to, let's say, put OpenAI or plug in OpenAI here, you can. I just thought that it would be much easier to show it with the local LLM, and not having to rely on the internet. Hmm. Yeah. So I think that's mainly on the verification side of things that you're asking, which is like, how much do you give the flexibility to the person that is using the SDK to upload the data on this network, if I'm understanding it correctly, right? But I don't think that that's the way to think about it. I would much rather make it as simple as possible for anyone to use it. The agents are just the best thing where we're seeing a lot of developer activity go in without necessarily thinking a lot about the infrastructure and so on and so forth. So if people start using it, it would be uh, very easy for it to evolve. But there are few things that are on this roadmap. For example, one of them is to enable encryption on the output level. We have the keys concept here, these things, but we don't do the encryption just now because we did it as a very quick experiment. But if you want, or if anyone is using it even further or wants to contribute it, and that's the thing that we are aiming with this, and that's why it's so easy to add any provider. We don't care where you're storing it. It's as long as you have a way in which you don't need to think about where to put things and how to get them back. uh, Things should be like very straightforward. Otherwise it becomes too complex for people to, for example, if you're using AWS SDK directly instead of relying on this interface, you would not have the ability to move away from that or take that data and move it to the different thing. So just those are the things that it abstracts out or makes it simple, and that's why we try to keep the interface as minimal as possible for anyone to extend it actually. Hmm. So in this case, the access control is something that we baked into the what do you call this collaboration smart contract that we have. But you can actually use that as the base premise and make it evolve as well, right? So we're working on this granular permissioning module that you can enable on the smart contract level and then get multiple people to collaborate on the output as well. But that's something that I would say that we left as a primitive piece, like meaning you get the base layer first and then you do things on top, step by step, for things to have room to develop or grow in a sense. Yeah.
One direction, if you're familiar with HATS protocol,
Yeah.
is one way we're thinking about the access permissions for that. Let's say you don't want completely open shared memory. You want some DAO members to be privy to the conversations happening between some type of agents. So you distribute hats on chain, and those hats have the logic to actually give you access to certain types of decryption of whatever kind of content has been outputted by the agent.
Yeah.
Yeah.
Yeah. Yeah. Yeah. Yeah. On the content registry, you can get the basic access control. For example, you can add collaborators to a portal or the contract that we have done, and those can either add stuff on that content registry. And that's why I was saying, like, you can add actually one more module called granular permission on it, and you can make it evolve even further as and when you need it. Yeah. Any other questions? Mm-hmm. Yes. So that's the that's what I think we left it as an open thing, and that's why we made it. We try to keep the SDK as minimal as possible, um, and as extensible as possible. So both sides are there. If you want, you can connect to local LLMs, like I said, and then you can have, for example, in this class, I just have the chat interface that needs to be available, right? So you can tweak this and say that I want to, instead of I want to do olama.chat, it's openai.chat, right? And it would still, rest of the things are the same, meaning .md output, the content registry being used, and data being stored in a way in which it can move from one registry to the other. So there is no vendor lock-in or any kind of things that can happen there. So yes. Hmm. Yes. Uh, yes. So I'll show you the thing that we did, and that's why it's the actually just the infra piece that we did. So we have we use Pimlico actually to sponsor the transactions. We're using ERC4337 in this case. So in like if you have Pimlico subscription, you actually just bring that in, put your API key here, and it works. If you have Pinata account, you bring that in, you put that here, and it works. So there is nothing actually that you need to pay to Fileverse in this case. It's just that you're just reusing that shared memory space that we have built, and that is going to exist um, for as long as the blockchain
So it's
exists.
basically bring your
Yes,
own subscriptions and
exactly. Yeah. Yes. So we're we don't bring in the LLM context in the SDK, and that's why it's a bit more clean, and you don't even need to think about it. So if you want, you can use it for LLMs. If you want, you can use it for something else as well. Yeah. Mm. Mm. Mastra. Hmm. Yes. Perfect. Uh, what do you want? Content addresses. Ah, the smart contracts. I think it's wait. It should be here. I can smart contracts. Yeah. So it's open source. You can go to this contract. This is the main contract. This is the contract that we are reusing in a sense. And like it's the same ABI as well. So if you want, you can check this out. And if you have any questions, happy to answer.
Because it's a contract we developed originally for ddocs.new,
Yeah.
our app. It's something that we've worked a little bit more on. You'll see it develop. Also, you'll have extra modules for like granular permissions, like we explained. And it's been audited by Nethermind
Yes.
twice, just for an extra layer of security.
Yeah.
Yep. What types of applications do you think will benefit from creating or consuming this data interaction log on chain? A bunch of them. One is it's much more ideological. Uh, this is a good way to move away from walled gardens, and it's the early days of AI. It's important to do it now, so it's more of a general use case. Second is at least those that have already downloaded the package or tried out the SDK have been using it for governance on chain, and some for trading strategy reports. So you have a bunch of agents that have been tried out right now on crypto Twitter, and they're mainly doing some kind of trading on behalf of their users. But the ones that are a bit more evolved also share a strategy. Okay, what they followed, based on what are the parameters that were considered in the trading strategy, and they post it on chain. Some are forced to because they're part of like agent syndicate, whatever. And sorry, they post it on a server where every agent is hooked up on and can take that data for refining their own trading strategies. But if every agent or people that want to create a shared memory layer start posting it in a way that is addressable and readable by everyone, you start seeing something that is much more collaborative. You don't need to double work and have 1,000 agents doing the same processing and have a very similar output just because they're completely unaware that the same request has been done a million times because you don't have access to the output of a process that has been yeah, released before. So that and some other stuff we can discuss. Any other question? A few things. One is Vijay and I, we're developing, again, ddocs.new. but we have a little itch constantly about not doing AI stuff. Vijay has been developing AI for a long time. I'm finishing my PhD on AI and cybersecurity, so we wanted to have something AI based. And then we noticed that okay, within the first 8 months of hyper hype on crypto Twitter around AI agents, it's like we weren't the crypto industry. It's as if we forgot everything about our values, everything about decentralized systems, and we all went for whatever was the simplest, open AI package, API, whatever. Everybody is using that shit. And, there is literally no difference between the powers of centralization happening in crypto AI agents, which every VC in the world is throwing a bucket of money without understanding basics. And it's the same in the Web 2 world. So we wanted to start maybe a conversation in a very practical way on, okay, what's the crypto response to something that is supposed to be a bit more decentralized? Yeah.
And from my side, I think it was two things mainly. One is like the the vendor lock-in that you get into when you're using these systems, where you're not, whatever you are saying is being used to retrain and do all of those kind of things, while also not giving you the guarantee that if the company goes bankrupt, you don't have anything left. Whatever you had the interactions with, whatever you learned, whatever you talked or chatted with your agent is lost. That's the first point. And the second thing is it's not, it gives you an healthier alternative to the current status quo, which is come to us, work with us, or like work on our platform, and that's it, right? We don't owe you anything and things like that. And I think this gives you a way in which you can actually make products that are using the API keys, and then give or keep that data control with the users where you want it actually at the end. So like being able to be self sovereign, being able to be for example independent of any policy change issues that come with these AI agents and systems. I think those were the two major things that I think were technically like pushing or asking that yes, we need to do something. Yeah.
Thank you very much for listening.
Thank you.